A warm welcome to everyone joining the VMworld 2021, and thank you for tuning in. I'm Karthik Krishna, Product Manager at VMware, working on some brand new and exciting solutions for the service providers and Edge. With me, I have distinguished all-star speakers from BT, KX, and Ori. We'll talk about how Edge Cloud lets telcos reinvent their role in creating a new internet. Andy, the Senior Manager, Mobile Core Networks Research at BT, will open the discussion and share insights on what's exciting at BT Research Labs. Paul, SVP and Head of Telco at KX, will show us some cool Edge use cases, and Jose, VP Telco Strategy, will speak about Ori and how it plans to reinvent the MEC space. Here is a disclaimer. I'll pause a few seconds for you to read. Today, we'll talk about a range of Edge use cases that BT Applied Research is working on, 3 example MEC use cases of today delivered by KX. A POC that we'll talk about is KX on the Ori Telco Edge Cloud of BT Applied Research, how Ori and VMware together reinvent the role of telcos, and what's next, a world of opportunity awaits.
Hello, everybody. My name's Andy Corson-Petrie, and I lead the Mobile Core Networks research team within BT Applied Research. BT is the UK's leading telecoms and network provider, and a leading provider of global communications and services and solutions serving customers in 180 countries. Within our applied research activities, we've been working on things like network slicing and private networks. But today I want to talk to you about the edge. Edge computing is talked about everywhere these days. But what is it? And what technical options do we as BT have? And what opportunities should we be focusing on? We've been deep diving into all aspects of edge computing in several projects and proofs of concept over the last few years. We have a hypothesis that huge opportunities exist for mission-critical enterprise services, and that there's a route to significant value for operators like ourselves in exploiting unique network capabilities, including the edge, that can deliver the reliability, security, and quality of service needed by these services. Although changes in demand can happen quickly, it's true that the timing of technology change is driven by the commercial considerations of the customer base. The global mobile industry as a whole has settled into roughly a 10-year cadence. 2G was around 1990, 3G around 2000, 4G around 2010, and now 5G. In the UK, BT led the rollout of 5G, launching service in May 2019, closely followed by our competitors, so now that all the UK operators have live 5G footprint. Across the world, as you can see, 5G launches are continuing to take place, with several countries now receiving 5G service from at least one, and in some cases, all operators. Next slide, please. So I'd like to talk briefly here about this wide range of use cases that we're exploring within our research activities. You can get an idea from this slide on a huge variety of topics, such as healthcare and education and the Internet of Things, smart cities, holographic communication, etc. But this includes things like AI-driven smart cities and ports and factories, and smart logistics, as you'll hear about shortly. Next slide, please. Here you can see the different definitions of edge compute, from on-premises edge to deployment at the base of the cell tower, as you can see, and so on, deeper and deeper into the network. Each location gives its own potential gains in terms of latency and performance. But of course, that needs to be balanced with the cost of deploying compute to lots of network nodes and the cost of the transport network as well. For our own use, we may, for example, decide to push our own 5G user plane out to these edge locations, or host elements of the disaggregated RAN. On the right-hand side, you can see the public cloud. This is where the AWS, Google Cloud, Microsoft Azure Edge, etc. This is where apps are hosted today. Of course, these companies are making moves into the edge market in telecoms networks through initiatives like AWS Wavelength, for example. But what's the right approach for operators like ourselves? Do we build our own edge, or do we partner with one of the hyperscalers? We believe these are not necessarily mutually exclusive. We're interested as an operator in exploring what makes our best network unique and different. What capabilities does our network have, and how can we bring those benefits to the mission critical services and applications that our customers actually want? We want to integrate with our network via APIs and apply all this to what's called the Telco Edge Cloud, as you can see there. Our research work is focused on exploring the opportunities for the Telco Edge. Let's look a little bit more at what that means. Next slide, please. So we've been working with other operators and partners within the GSMA as part of the Operator Platform Group, or OPG. This group is focused on defining the requirements and architecture for this Telco Edge platform, integrated with operator networks that can also be federated between operators. There are two key points that I want to bring out here. The first one, if you could bring up the next call out. The first one is what's called the southbound interface. This is the interface to the network resources. And we're interested in this because this is going to be a key part for mission critical services, for example, V2X, vehicle to infrastructure. This would be used, for example, for an application to request a specific quality of service from the underlying network via this interface for the delivery of the traffic, and thus be able to offer the required quality of experience for the end user. If you could bring the next call up. The other key interface for us of particular interest is the east-westbound interface you can see here between operators. And this enables federation between edge cloud operators, allowing us to consume resources, for example, when our customers roam. Again, V2X could be very relevant here as drivers travel across countries and roam. We believe there is value for operators like ourselves here if we leverage these opportunities. We don't just host the app, but can exploit the capabilities and reliable connectivity of our network. For mission critical services that we're targeting, we're going to need both. So you've heard about a little bit about our research interests and activities, about the different types of edge, and some of the key architectural concepts that we're looking at. But at the end of the day, this is all about being able to run the applications and use cases that our business and customers need. So now I want to hand over to Paul from KX, who will dive deeper into a couple of these use cases previously mentioned, before we explore a little further Ori and VMware solutions in more detail with Josie and Karthik. But for now, over to Paul.
Thanks, Andy. So in these next three examples, I'm going to reference the edge a lot, obviously, and I just wanted to talk about that a little bit. So that particular edge could be a device edge, like a single sensor in the factory. It could be a MEC, mobile edge compute, or it could be an on-premise customer edge, or indeed a metro edge, where things can get particularly interesting, where you start to operate at a system of systems levels. So you get a much bigger geographical scale. And it's important that we understand during the use cases that it may not just be one particular edge, but multiple tiers of edges that are required in order to bring the business benefit. Now, to all of these examples, the common theme is that there's a central silo. There's a single system. And in order to derive that new enhanced business value, we have to get these systems to communicate and collaborate together in that system of systems type way. If you want to try and automate a port or city, there's lots of different systems. If you want to do it at a country scale, you need to be able to bring them all together and not just operate as a single piece or a single tool. And that's really where the whole idea of the telco edge comes into play. You know, when you can facilitate that level of interconnectivity, having streaming data from thousands of sensors, different systems, it's all being analyzed. You're doing automation on top of that to try and bring real-time, in the moment, frictionless type control. And that is just not possible unless you have that collaboration connectivity that's facilitated by the telco edge. And we're going to see that more and more and more. into the future as there's more sensors, more data. Trying to do something from a remote central location is just not going to be feasible. In the particular first use case I'm looking at here around port logistics and management, I want to try and give you some background really to when we look at ports. People tend to see containers and trucks and ships, and they see large automated cranes and robotics, and they get the impression that it's very efficient. Now, in reality, that's not the case. Everything is working individually. The systems aren't interconnected. And this is really what our client wanted to solve. They wanted to bring greater efficiency. So they want to improve the port logistics efficiency through new, smarter services, predictive behavior across the different systems, and integrated scalability. And in order to achieve those three goals, what we needed to do was bring the systems together, those different silos, create a new one, and do it in such a way that it didn't cause data privacy breaches, which is very important, obviously, or leak any kind of commercially sensitive information from the different silos. So obviously there's a lot of co-opetition between different companies, all working together within the port, but you got to make sure that that sensitivity is covered. And before the solution could be put in place, it was that lack of cooperation that was really causing the time delays, costs, and lost resources. And as I'll show you now in a second on the next slide, in Helsinki, how we managed to solve that particular problem. So this particular screen was produced as part of the overall solution by one of our client partners, Urban Institute. And as I mentioned before, it was for smart city implementation in Helsinki. And I'll cover some of the elements of the screen as I talk through it here. But really, when it comes down to it, as Andy has mentioned, the key part here is about the business value that these edge solutions can bring. And so what did this actually bring for the end client? So in essence, it brought 5 improvements for that client. The main one was around accurate forecasting of when containers can be released. Now that might sound very simple and rather bizarre, but what used to happen is that trucks used to travel across America, basically from port to port, or sorry, Europe, across port to port, to try and get their container on time. Because really the only fixed thing with these massive ships is the sailing time. The ship will go whether the container is unloaded or not. And that's the key thing. And by being able to do some of the forecasting, which I'll talk in a second, they managed to solve that problem. The second key gain they got was around reduced carbon footprint. And in fact, that was the main reason why this particular project was funded by Horizon 2020. What was happening was that trucks would be waiting for hours and hours, and sometimes even days, for the particular use case that's shown on screen here. As you can see, the container is blocked. It can't be done, can't be released. And what would happen, as you can imagine, in Helsinki, where it's very, very cold in the winter, you've got drivers sitting in their cabs, burning fuel to try and stay warm as they're waiting for containers. One of the key things from a port perspective is actually better efficiency, obviously. So you don't have time wasted for drivers wasting. You don't have them actually coming in too early, blocking up the ports. You've got parking. You've got truck utilization for the actual logistics companies themselves, and indeed container space. So again, in order to get that kind of high throughput through the port, you don't want to be filling the place up with containers. And the very last one, key important one, was around crane utilization. So what they used to find was that they might use very heavy cranes in order to lift very light workload, or indeed, even worse than that, they do the opposite. And they also found that time was being wasted on crane availability. So a large ship would come in, very heavy containers, need a particular type of crane, or indeed the resources around it to manage those cranes, just wasn't available. And again, brought wasted time. And really what we're saying here is that by being able to bring all the different systems together, bringing the machine learning on top of it, you're able to get those 5 different gains. But that's an awful lot of data to try and bring together. And so really for this particular use case, what we had to do was do a private LTE installation at a customer edge, bring all that information together at the customer edge. We couldn't bring it into the cloud and try and do the response times that we would want. And also, as data volumes are only going to continuously grow and grow and grow, it just became more inevitable that this needed to be done on the edge, and indeed may in fact have to move to a more like a metro edge, because some of these very large ports are really operating at more like a city level. Next slide, please. So now what I'm going to talk about as a second example here is around smart manufacturing. It's probably one of the most popular use cases and application of the edge that we see today. What I'm going to talk about a little bit is really around the business problem and how we solve that, and indeed worked in conjunction with one of our clients, Applied Materials. We use our technology to power their applied smart factory solution. The key part of that solution, or what the goal of that solution, is to improve tool and process performance. And ultimately, that will lead to yield optimization and preventative maintenance for the original manufacturer. This particular use case, and as I said before, is very popular. We see it being asked a lot, both to ourselves and also through operators that we work with. There's lots of publications about it. You may have seen Samsung and AT&T come out with a joint announcement about using 5G for more efficient manufacturing in plant in America. And you can see throughout Europe, lots of the tier one operators are coming out with similar announcements. If I look at the left-hand side of the screen that's been presented there, what it's trying to show you there is the data volume increases. And a lot of people, especially at the moment, are looking around chip manufacturer and they're looking at, well, nanometers. So when the nanometer decreases from 5 to 4 to 3, as you hear in the press, what that actually means in terms of data is that the process steps actually goes up threefold for every single time you drop it by 1. And that's where you see in the graphic on the right-hand side, the third one, such a massive increase in data volume. And what that ultimately led is that on average, if you had a plant, say, with like 1,200 tools, which would be kind of a common enough size, you'd be generating 30 gigabytes a minute. They would always like to try and retain it for 90 days. So you're looking at 4 petabytes of data. So there's just no way that you're going to try and backhaul that up to a centralized cloud all of the time. It's just not feasible. And indeed, we have clients coming to us who are starting to have SLAs around control. So what I mean by that is that you must upload the data, process, run your algorithms, and then respond within a very narrow fixed window size. That could be anything from like 100 millis, 300 millis would be a fairly common request. So trying to actually bring all of that data up through the bandwidth, up into the cloud, do your calculations and reach back in and take action based on that batch, there's just not enough time, even if the cost was something that could be contained. Next slide, please. So this is our third use case here, and it's around telematics and logistics. What we're going to show, a little video coming up next, but what we're going to show is basically a use case that we did across Australia, where we were simultaneously streaming in lots of data from hundreds of different, thousands of trucks as they traversed Australia in very much near real time, streaming all of the data into KX streaming analytics engines, where we run all of our ML and start to take some action on some of the use cases, which I'll talk about in a second. Now, the reason this one is a little bit unique and different is that because of KX's low hardware footprint, you can actually install it in the truck, in the vehicle. You could install it on a mech, you can install it in Telco Cloud, or indeed even part of it in a central location if you wished. And it's that tiering again, which I know Jose is going to talk about in a few minutes, that's of particular importance for this one today, but I think even more so in the future as data volumes go higher and higher and higher, as our vehicles start to become more automated, start to generate more data. It's really going to be absolutely required that a lot of this processing is done on the edge, especially when you look at some of the use cases that have been brought out around, again, control, around trying to notify different vehicles on the road, or indeed different infrastructure of what's happening in real time. This particular use case, again, if I go back to the business benefit, what did this bring for the clients? It was very much focused on fuel efficiency. It was around logistics tracking in near real time. So where exactly is my pallet? We also focused a lot on driver behavior. You'll notice it here in the video, route optimization. There's lots of other use cases, but they're probably the main ones. And indeed, the corrective action that can happen as a consequence of those, which is now coming into the actual vehicles themselves. So it'll notify the driver if it's a driver behavior scenario, if there's a hazard in front, for example. Next slide, please. And this little video will kick off, and you'll see where we were tracking in real time the trucks across Australia. But really what this brings me to is more around what's next. You know, these three use cases that I showed you really show how we're bringing digital transformation to our business, you know, and how it's possible with more automation, edge interconnectivity, analytics layered on top, especially when we're looking at distributed and federated edge. We really need to start focusing more on that system on systems at the federated edge, where you can get more of these business benefits, these new use cases that can't be done before. And it really is, by bringing it in real time, you can get that frictionless experience, bring in your streaming data, your analytics, your interconnectivity. And as I said before, you can really only do that with your telco edge. Next slide, please. And this really brings us on to, I suppose, the POC that we did jointly together. And in fact, it was the telematics use case that we implemented in BT's R&D lab, really trying to prove the point around how to show support for mobility. So mobility of user equipment as well as applications. From our experience, from my particular experience on it, with the Ori Cloud, we found it very easy to integrate, run our technology on the telco cloud, to serve lots of different use cases, lots of different verticals. And this telematics was just a simple example of one. And it's that simple integration that we can just repeat over and over and over again for all our customers that really makes, from our perspective as an ISP, why we were so keen to work with the VMware and Ori on this telco edge cloud. I suppose that's from our perspective. Andy, maybe what would perhaps be, from your perspective, from a BT?
Yeah, from our perspective, I mean, like you said, Paul, the work that we're doing is aimed at proving the benefits of these apps that can run in the telco edge cloud through these real-world use cases and data. But we see that the telco edge cloud can serve many different industry verticals and ISVs like yourselves at KX. And when you bring the technology and the edge-ready applications to the party, that opens up a world of possibilities.
And hello everyone. I'm Jose Domingos. Thank you, Andy and Paul. Yes. So this proof of concept with Ori's platform software, BT's infrastructure, the KX use cases running real customer data, have allowed us to explore real world use cases. That was the whole point. And really, we're demonstrating that the edge cloud is relevant today and can deliver business value right now. Identifying this value is critical to develop the edge ecosystem. The work allowed us also to circle back to the GSMA OPG, the operator platform group that Andy mentioned earlier, and see how the standards that are being developed there are supporting the actual requirements of the edge market, its customers, its solution providers, and how we can address their pain points, essentially making those standards better and more relevant. Next slide, please. The Ori Global Edge is a managed cloud service offering that provides intelligent workload placement across multi-cloud, OriNet, Telco Edge, and Enterprise Edge layers, as you can see on this picture. The interoperable Ori and VMware solution delivers a hybrid edge with leveraging multiple Ori POPs that connect to the CSP infrastructure on one end, and different clouds on the other end, such as Azure, Google Cloud Platform, and AWS. These regionally located nodes are the connective tissue that enables Ori's intelligent workload placement at the edge. The solution provides CSPs with the ability to take infrastructure that potentially isn't being used or that is being used infrequently, or should it be the case, new infrastructure that they wish to designate for this purpose, and expose it for other external uses and applications. That's the point of the solution. Through a simple, the provider branded portal, Ori Global Edge allows then customers of this cloud to dynamically place workloads across on-prem, Ori nodes, the Telco Edge, public clouds, and so on, as a continuum of infrastructure. VMware infrastructure is handling the dynamic changes, the scaling up and down where necessary from a single source, and dynamically allocating workloads as needed. The key benefit of the combined Ori and VMware platform is the ability to dynamically place and connect workloads at the edge of the network as close as possible to where the actual work is needed and being done. So the end user experiences low latency, close to real-time interaction. That's the point of this. I.e. high performance. Workloads can run anywhere depending on the needs of the application, and of course, depending on the available infrastructure, the cost of that infrastructure, the performance, etc. Ori Global Edge, running on the VMware Telco Cloud Platform, provides a consistent methodology that simplifies the deployment, delivery, connectivity of low latency applications and services from these multiple networks and regional metro POPs to potentially thousands of distributed providers, edge sites, and on-prem locations. This global edge architecture seamlessly connects edge networks between different regions and providers, enabling CSPs to deliver their enterprise customers a unique solution that combines the deployment flexibility and lifecycle manageability of cloud with the performance and security of edge and on-prem. Next slide, please. And this is how the Ori Cloud is deployed together with VMware infrastructure. As you see on this picture, the OriNet, right in the middle, is where the centralized control plane and orchestrator of the edge cloud exists. OriNet implements a multi-tenant platform that supports multiple separate operators with their own branded portal UI and APIs. That's Telco A, Telco B, Telco C. Those operators can form federation agreements through OriNet. And of course, cross-charging between telcos is possible with usage charging APIs and capabilities. OriNet peers with public clouds for true multi-cloud and links to the telco network where the central and local multi-access edge compute sites exist. Additionally, there may be on-premise private MEC sites with private access networks at enterprise locations or other organizations such as government and so on. All these MEC sites are able to be automatically onboarded onto the Ori Edge Cloud thanks to VMware Telco Cloud Platform and Ori's onboarding APIs. I'll let Kartik talk a little bit about the VMware.
Yeah, thank you, Jose. And as you might guess, right, VMware, true multi-cloud capability, right, provides consistent horizontal architecture across provider and edge clouds that you see here, right? Enabling consumption of services from different public clouds. Now, the Telco Cloud Platform that you see there, right, allows a flexible footprint by launch, connect, and scale of edge sites seamlessly. Ori's APIs interface with the Telco Cloud Automation APIs, and the Telco Edge Cloud can be created with a few simple steps, and we'll show that later in this presentation. This reduces operational cost and increases the ROI for the telcos. Jose, yeah.
And the final major differentiator of the Ori VMware solution is the availability of a catalog of ISVs, of which KX is one of the main featured partners, who can immediately start to commercially exploit the Edge Cloud. These ISVs have hedge-ready use cases, and they can start to monetize this infrastructure right away. This infrastructure, this transformation brings a true hybrid multi-cloud platform, delivering the benefits of public cloud, but with the performance of the cores on the edge. So these are the three master pillars of monetizing the Telco Edge Cloud. Number one, you can leverage any of VMware's Telco Cloud Platform and Ori's technology to quickly onboard MEC sites into the public edge cloud, reducing operational costs, increasing automation and ROI of existing solutions. Number two, Ori's cloud APIs allow ease of deployment of workloads anywhere on the distributed cloud across different gradients of edge, and simplify the connectivity between those workloads and from workloads to clients. And number three, the edge ecosystem with edge-ready applications and use cases from many ISVs such as KX, pre-integrated on the Ori VMware Telco Cloud solution. We're not just bringing the business case to CSPs, we're actually bringing the business.
And we'll talk about the solution here, right? VMware Telco Cloud combined with Ori's Global Edge provides a unified solution for CSPs, and that allows CSPs like BT that allows them their enterprise and ISV end customers to move applications and data from the cloud to the provider edge seamlessly with a uniform developer experience. Ori Global Edge is a managed cloud service offering that provides intelligent workload placement across multi-cloud, Ori Edge, and enterprise edge layers. Right, this is what Jose spoke in the previous slide also, right? VMware Telco Cloud Platform is powered by field-proven compute and network of VMware Telco Cloud infrastructure, coupled with VMware Telco Cloud Automation and VMware Tanzu for standard for telco. A telco grade Kubernetes distribution, that's what it is, right? VMware Telco Cloud Platform delivers true multi-cloud capability by providing resource abstraction for compute, network, and storage for both virtual machines and containers. Ori Global Edge running on the VMware Cloud Platform allows CSPs to focus on delivering value for their end customers and deliver a vast array of use cases, including manufacturing, retail, transportation, smart cities, and healthcare.
The Ori Cloud Platform provides a cloud portal for ISVs and enterprises to access edge cloud services. Right on top. These edge cloud services are, of course, exposed through a UI or through APIs for integration with deployment pipelines. The major constituent technical blocks of the solution are a flexible and powerful multi-tenancy solution addressing the needs of service providers and their customers alike, an intelligent application orchestration capability for optimally placing workloads on the distributed edges and supporting the lifecycle management of those applications. And finally, integrated networking capabilities, bringing powerful and simple interconnectivity between workloads and from workloads to clients securely. These capabilities are designed to support the needs of the CSPs in running their own edge cloud platform and the needs of ISVs and enterprises in consuming edge cloud services to run their applications with optimal performance.
What we know is both providers and ISVs require a consistent infrastructure to run workloads, and that can scale as needed. That's what they are looking for. And that's what we have here, right? VMware provides unified edge compute, that enable operators and enterprises to start from any edge workload, that flexibility, right? And expand to other workloads on the same infrastructure. The possible scenarios could be providers can start with a private connectivity, right? A workload like a 5G, a RAN at the edge, and then extend to the MEC applications. Or they can start with the MEC applications and then add the connectivity workload as they seem fit, right? Total flexibility when it comes to the edge compute. The multi-cloud computing that I spoke right in the previous slide also, right, provides consistent infrastructure for all types of applications, legacy, cloud native. Providers can easily scale from a single server to many server and scale to multiple edge sites, right, at the edge. This is the key here, right? The flexibility and the scaling aspect at the edge is really key, and all needs to be managed from a centralized location, right? And automation is the holy grail when it comes to the edge computing. Multi-layer automation, really accelerates the time to market and increases the scalability, repeatability, and operational efficiency, right? Those are the key pillars. CSPs, including telcos, cable operators, and mobile operators, right, are uniquely positioned in this new edge ecosystem with their edge networks and points of presence that are closest to the enterprise customers, providing connectivity like 4G, 5G. Yeah, but the complex, siloed architecture of, some of the CSP networks often, stands in the way of deploying applications on the edge, especially when an enterprise is encumbered by rigid resources and unforeseen shifts in demand, which is, kind of the nature there, right? A VMware Telco Cloud combined with Ori's Global Edge provides a unified solution for CSPs to allow their enterprise and ISV end customers to move applications and data from the cloud to the provider edge seamlessly with a uniform developer experience by peering between clouds and connecting multi-vendor networks through a single platform. The VMware Telco Cloud Platform, right, delivers true multi-cloud capability by providing resource abstraction for the compute, network, and storage. It delivers consistent horizontal, architecture across provider and edge clouds. This enables, consumption of services from different public clouds. Lastly, the Telco Cloud Platform allows a flexible footprint that I talked about by launch, connect, and scale of edge sites seamlessly. Jose?
And summarizing, Ori Global Edge is a managed cloud service offering, provides intelligent workload placement across multi-cloud, Ori Net, Telco Edge, and enterprise edge layers through a simple provider-branded portal. Ori Global Edge allows customers of the cloud to dynamically place workloads across on-premises, Telco Edge, Ori Cloud, public clouds, effectively anywhere in this continuum of infrastructure. That's the idea, the main idea behind it. Ori Global Edge running on a VMware Cloud Platform allows CSPs to focus on delivering value for their customers and creates opportunities to provide new products and new services for a rapidly growing ecosystem of applications and digital services. CSPs can in turn deliver increasingly rich experiences for end users in gaming, in delivery of content, in media and broadcast, in retail and enterprise sectors, manufacturing, and so on, as well as breakthrough technology solutions in healthcare, in manufacturing, smart cities, smart ports, with that we've seen through the use cases of KX. Okay, and I'll hand over to Andy, who's going to.
Thank you, Jose. So what comes next? We're exploring a number of capabilities. Perhaps you could step through the build up here, including edge discovery, a network differentiation, intelligent workload placement, and federation, as we've mentioned. And we're driving the work that we're doing with Ori Cloud to demonstrate real opportunities for our business in the market today and tomorrow. Next slide, please. So to summarize, there are a wide range of new applications and services for all sorts of industry verticals and markets being considered and developed. Some are ready today. Some will succeed and grow, others may not. Some which we've not even thought of yet will turn out to be the indispensable tools of the future. Some will grow with changing circumstances. You only have to look at the rapid growth in video conferencing over the last year or two and how well it has been accepted by the end user. So we're building today and for the future. As part of this, we think there are many key capabilities needed for operators like ourselves to offer these differentiated mission-critical services to our customers using the technology from our partners and colleagues, as you've heard here, so that we can unlock this future value. Thank you very much.
Thank you, Andy, for sharing those insights on what BT is planning to do and what you're doing at BT Research Lab. And thank you, Paul and Jose, for sharing your insights on these cool edge use cases that you're working on. Um, just want to close out by saying, come and visit us. Come and visit, us, Ori, VMware, and KX. We have a demo zone at VMworld. We will demonstrate how service providers can monetize their edge in really three simple steps, right? Step one, we'll show how to transform the telco VMware infrastructure into a public edge cloud. The step two, how we enable streamlined deployment of workloads across telco edge cloud environments and connect them to the enterprises. And step three is where service providers and enterprises access to a large ecosystem of ISVs like KX with edge-ready use cases deployed on Ori and VMware combined telco edge cloud. So please reach out if you have any questions or if you would like to see a demo of the solution in your environment. Thank you so much. Please take your survey. Thank you. Thank you for joining our session. Thank you.
Thanks, everyone.
Let's look at, first, transforming VMware infrastructure into a public edge cloud in a few simple steps. Second, streamline deployment of workloads across distributed cloud environments and connect them to the customer environment. Third, choose from a large ecosystem of ISVs and edge-ready applications for immediate deployment. Now, let's deep dive into transforming your VMware infrastructure into a public edge cloud. After an end user logs into the Ori dashboard, they select or add the appropriate infrastructure platform provider. In the demonstration, we selected VMware's Telco Cloud Platform as the infrastructure provider. Let's set the VMware Telco Cloud Automation API location and enter our VMware credentials. The next step is to enter basic information about the type of workload cluster template that the user would like to create. After creating the template, we can proceed with the creation of the clusters. We have successfully onboarded a new edge site to our Ori Edge Cloud, and the site is now ready for instant deployment of workloads. Next, we will look at the secure process to deploy and run a workload on the Edge Cloud. Once logged in, an application provider can deploy containerized applications in its secure project tenancy. It is now possible to enter a container image and corresponding credentials. Next, provide variables, input commands, and expose any networking details. And finally, decide which infrastructure to deploy on. Let us deploy the application on the new Edge site we created earlier. As you can see, workload deployment was possible with just a few clicks. We enable a secure and flexible tenancy model where APIs allow automated placement of workloads on a distributed edge cloud, exposing these workloads to applications consumers. Ori's expanding ecosystem of application providers addresses a wide range of edge solutions ready for your new edge cloud. This example will show you 3 streaming capabilities of KX's real-time data capture and analytics solution. Within high-tech manufacturing, large-scale data collection on manufacturing plants is essential for process control and automation, as well as fault detection. Tens of terabytes of data are collected daily, which need to be analyzed in real time to enable efficient in-process control. Preventing failures or increasing yield in these environments can have very significant economic and environmental cost savings. The Telco Edge Cloud, built with VMware and Ori, can deliver these and many other such use cases, bringing the new era of Industry 5.0. In this presentation from Ori, VMware, and our ISV partner KX, we have demonstrated the substantial opportunity to telcos and CSPs for the establishment of an edge cloud built on VMware with Ori Global Edge. The 3 KX examples demonstrate the innovations available for telcos and CSPs looking to quickly add new services on their existing networks.